Mankind has been fascinated with cold since the beginning of time, but there was one question still left unanswered. How cold could it get? The first man to devise a way to create extremely low temperatures was Michael Faraday, known more for his studies of electricity and magnetism than of heat. He discovered that if he liquefied gases such as chlorine, carbon dioxide, hydrogen sulfide, and hydrogen bromide, he could reach extremely low temperatures. His experiments stopped when Faraday realized that he could not liquefy oxygen, hydrogen, or nitrogen, which he called the permanent gases. He gave up and shifted his attention to other studies. The lowest temperature that Faraday accomplished was negative 130 degrees centigrade. A Dutch theoretical physicist named Johannes Diederik van der Waals finally explained why the three permanent gases were not liquefying. They needed to be cooled to a certain point so enough bonds would be broken between the molecules that they could liquefy. Oxygen and nitrogen were soon liquefied. Nitrogen reached a record low temperature of negative 200 degrees centigrade, but for some reason, hydrogen wasn't liquefying. It wasn't until Scottish chemist and physicist James Dewar, not to be confused with the inventor of the Twinkie who shared the same name, created a cooling system that gradually cooled the hydrogen until it could be compressed and therefore liquefied. The liquefied hydrogen reached negative 253 degrees Celsius. The race for absolute zero had begun. Dewar was not the lone contender. He had a rival, Kamerlingh Onnes. Though Dewar had won the race to liquefy hydrogen, if Onnes could liquefy helium first, he would have a strong lead in the race. Dewar could not obtain a supply of helium very quickly, and when he eventually did, there was a leak in the tank the helium was contained in. Onnes was the first to liquefy helium. Liquid helium reached negative 268 degrees Celsius, just 5 degrees above absolute zero. Dewar went mad with rage and shifted his studies to soap bubbles. All this talk of long, confusing, negative numbers was getting, well, cumbersome. So British mathematical physicist Lord Kelvin decided to do something about it. He developed a scale which is known today as the Kelvin scale. Absolute zero, which is negative 273 degrees Celsius, in the Kelvin scale is simply 0 Kelvin. Now, for decades we thought that reaching absolute zero was impossible, but as science has a tendency to do, it has defied the impossible. In January, we reached temperatures below absolute zero with a quantum gas. I won't attempt to explain it to you, but it's amazing to ponder the possibilities of what such a temperature can achieve. This may mean that we can make a 100% efficient machine. The quest for absolute zero is officially over. Take some time to reflect upon the people, breakthroughs, and mistakes that led up to January. Is this the coldest that we can get? Or are we only going to achieve colder and colder temperatures? Only time will tell. I'm Martin Beck for South Pole News Agency, signing off.
Hasta la vista, baby.